Okay.
All right, number 10. Let's see.
I read that one.
There you are. So this is no calculator, what do you think?
How do you take an integral to like multiply? Because there's no way.
There's no product rule, that's right. You can phone a friend. Does anybody have a suggestion for him?
I would factor
I was gonna say.
How do you do that?
You can do a year substitution.
How do you do that? You can't do that if it's a half hour like that.
Yeah, you could still do that.
Say it again?
I said you could do a year substitution.
Yeah, this is zero.
So go ahead.
Oh, I know. What is it? Oh, nice. Oh, good.
I'm sorry.
Yeah. Sure.
Sure.
No, there's two ways to do it. That's one way to do it, yes. Wait a second. I'm not sure what you're doing now. You haven't integrated. You're kind of undoing what you did, progress you made. You know what I mean? You integrate. What's the integral of u to the half? Yeah. So write that. So equals 1/3 times u to the 3/2 times 2/3.
Then it's just times
times 2/3 because you divide by 3/2. Does this make sense? Okay. And then evaluate that from 1 to 9. The bottom number tells you what root to take. The top number tells you what power to take.
Yeah, so 9 square root of that is 3, and then 3 squared is 27. But
Yeah.
27 times 2/3, that's what I'm thinking.
Well, it's 27 divided by 3.
9.
That's 2.
That would be
Okay, so what's the answer? Oh. Everybody agree? All right, nice work. And remember, the other way you could do this is without changing limits of integration. You could have said, make the same substitution. So you have the integral of u to the half times x squared times du over 3x squared. Don't change the limits of integration. This would be 1/3 u to the 3/2 times 2/3. And then change back into x's now. So this is 2/9 of x squared plus 1 to the 3/2. And then use the original limits of integration. And it would give you the same answer. This would still give you 3 to the 3/2 and 1 to the 3/2. It would give you the exact same answer. Okay? Any questions on that? Remember, they like to test you to see if you know how to do u substitution of definite integrals both ways. You got to make sure you know how to do it both ways. Okay? All right, good. Let's see. So next would be Maggie, but she's not here. So John, you're up.
uh,
17. I can't believe we haven't had a free response
I
question.
know.
17. Let's see.
Yeah, I guess you're right. Yeah, I guess I still have like a lot of yeah.
There it is.
Or yeah, next time.
Yep. Wait, there's a problem. What's the problem? Yeah. Wait, what?
There's two.
Yeah,
Yeah.
not chain rule, product rule. Yeah. Okay, wait. Anybody see a problem?
Yeah, that's what I was. You
Yeah.
multiply by the exponent's derivative.
The derivative of 12 e to the negative t is negative 12 e to the negative t, right? Chain rule? So that's the only thing on it. And no, in this one. That's positive. Because you got the first times the derivative of the second, plus the second times the derivative of the first. Cool? All right, go ahead. Sorry. I just didn't want you to get too far in and then have it work you wrong. Everybody paying attention? Is there any problem so far? Okay.
equation from?
John, you had to set it equal to zero. Zero.
Right, they want to know when is the velocity zero, not what's the velocity at t equals zero. See the difference?
Yeah.
Okay. You can phone a friend if you have a problem, you can ask.
Yeah. Would that be over two?
What are you thinking in your brain? Why do you? So you're thinking in degrees probably, right? So what are you thinking degrees would be?
I was more thinking. This is I over 2. So this is I over 4, right?
Yeah. Okay, great. Let's see. No, you're good. You're good. I just want to caution you, when you set a sum like this equal to 0, what you're really doing, instead of like getting stuff on one side and stuff on the other side and dividing, the problem with that sometimes is that the stuff that you're dividing by might be 0 sometimes. Now that's not the case here, but it might be 0 sometimes. So it's a little bit safer to take a common factor out. It's doing the same thing essentially, but it's a little bit safer because then you don't have to worry about that stuff being 0. So you do 12e to the negative t, parentheses, cosine t minus sine t equals 0. And you end up at the same spot. This can never be 0. This is 0 when sine t equals cosine t. And then in terms of the trig, you should definitely have memorized that the sine of 45 is radical 2 over 2, and the cosine of 45 is also radical 2 over 2. That's where they're equal. So it's 45 degrees of pi over 4. But good job. Any questions on this? Okay. We're almost due for a free response question. Aiden, come on up. I can't believe we've gone through this many questions that haven't had one yet. Did you guys secretly remove them?
Yeah, yesterday.
Oh, I see it now. Free response.
Oh, free response number 6.
That was rigged.
Is that a calculator or a non-calculator question? What do you think? Number 6? Is number 6 calculator or non-calculator? Non-calculator.
No.
4. There it is. So you just have to do part A.
Okay.
So this is a related rates question, right?
So, we want to know when the radius is 9, so R is going to be equal to 9 centimeters.
Yeah.
And then the radius is increasing at a rate of R prime is going to be equal to 3 over 2. Find the rate at which the area of the circle is changing at that instant. So area is equal to pi r squared. Reach the derivative. I think we just took the derivative. Pi a prime equals pi times 2 pi times and then equals 2 pi times 9 times 2. And then these cancel out. So a prime equals 27 pi. Then we get this meter squared.
Right. Perfect. Any questions on that? That was well done. Trying to think of a hard question. I can't really think of any. So remember, in related rates questions, I mean, the only thing I would have done differently is I probably would have drawn a picture, but that's not that big of a deal if it's just a circle. But sometimes a picture is helpful, especially if it's a triangle or some other geometric situation. And then I would probably give units of measure on these things, just so that I didn't forget to give units of measure on this thing. Okay? Any questions on that? That was well done. All right, who gets to do part B? Charlotte, you get to do part B. So I actually, the way I copied and pasted this, I think I copied and pasted, yeah, part A and then part B, just so you could remember like what the stem of the question was. All right, so there you go.
Okay.
Might be easier if you move for negative 0.5 times negative 12 first, divide by 6. And then 3 over 6.
Not a bad idea. So now I get here.
What are the units?
The units of this are just 2 seconds. But no,
Okay, I got one more hard question. If you were an AP writer and this was multiple choice, how would you write that answer in the most simple way? You don't have, this is perfect. I would leave it like this if I was doing this as a pre-response question, but I'm just asking, just so we can practice laws of logs, what would it look like?
well, this.
Yeah.
Why not? So maybe they might square this.
Square, you can't just square something.
Or, like. Like this.
Oh, I was thinking more like, if I was writing this, just to see if people knew what they were doing, I would write it as -2 ln1 minus ln2, because then ln1 is just 0, so you end up with 2 ln2. That would be, or even ln4. That would really mess people up. Does that make sense? So you have to get used to thinking about laws of logs and how they might write things, because that's definitely what they would do if this was multiple choice. Good job. Nice work. Paul, part C. So same thing. I copied and pasted parts A and B. So you can, it's tiny though, but so you can kind of see what the stem of the question was in case it requires you to know it. You're going to scroll down and give you some more room. Any problems with that?
You gotta put DT on there.
Okay, that's one thing. DT. You're at DT. Did you mess up somewhere else? Say that again? What do you think? Nobody sees a problem?
Can you let me look at it?
Yeah.
Yeah.
Do you have a suggestion? Anybody see a problem? Okay, when you're evaluating a definite integral, you plug in 3, and then you plug in 0. When you plug in 0, it's 0.
Yeah, that's right.
Good work.
So is that right?
In my brain, I was seeing +4, and then I was thinking, okay, so when you plug in 0, you don't get 0. But never mind, I'm stupid. Good job. Yeah, so the answer is stupid. I could have just looked at the paper. Excellent. Any questions on that free response question? That wasn't too bad, right? Okay. Is this game helping?
Yeah, that's fine. I like it.
All right. I mean, I'm just trying to do something that kind of, I don't want anyone to feel like attacked or judged, but I want everyone to just try and, see if they know what they're doing. All right. Who's next? Diego. No. Yeah, Diego, you're up, okay?
Okay.
All right. If it happens to be free response, then we're going to pick a different question because we don't really have time. All right, number 28. So this is non-calculator, multiple choice.
I just say so.
Dude, why does it seem like I'm missing some problems here? 13.
Check, page 4.
Yeah, check the previous.
Did I mess up? Oh, yeah, okay. Thanks.
It just got disorganized.
All right, there's 28. You tell me what's all right. So this is actually another related rates question.
I'm just writing the problem down right now.
Sure. Yeah, no problem.
And then H is equal to S. I don't know how I would make an equation relating the hypotenuse to the sides and then take the derivative of that equation.
Okay, they tell you it's an isosceles right triangle. What do you think, Paul?
So it would be like a 1, 1 radical 2.
Yeah, it's a 1, 1 radical 2 triangle. So think of this as like S radical 2, that sort of thing. Does that help?
Oh. So then, okay. One half.
Or another way you can do it that might be easier is think of it as like, this is H, and this is H over radical 2. That way, you can make the substitution. This is S, plug it in for S there. Then you have the area in terms of H right away. You know what I'm saying?
Yeah.
So if area is 1/2 S squared, then the area is really 1/2 of H over radical 2 squared. So the area is 1/4 H squared. So where do I go from here? What do I write next?
Oh, wouldn't you differentiate A is equal to 1/4 H squared?
Yeah, what do you get?
You get 1/2 H times H prime.
Yeah. Okay. So I know what A prime is. They tell us in the problem it's 12.
And then we know that since H is really just, we can take radical 32
Yeah.
and set it equal to H over radical 2, right?
Okay. Yeah.
to solve for h, and then just plug that in, and then
So what does h end up being?
let me just do it out real quick. Wait, h over radical 2 is, well, it would just be radical 32 times radical 2.
Yep, how does that simplify?
That is a good question.
Radical 32 times radical 2 is radical 64, right? You just multiply them because they're both underneath the radical. So you get 8. Does that make sense?
Yeah, so then h prime is just 3. So it would be,
I agree. Does everybody understand this? Now there's other ways you could have done this. Like we could have started with this formula, differentiated a prime equals s prime, right? We know what a prime is and we know what s is. So we could have said this is 12 equals radical 32 s prime. So s prime equals 12 over radical 32. And then you could have just written an equation that relates h and s, like this equation right here. H equals s radical 2. So h prime would be radical 2 s prime. That's it. And then you could just take this and multiply it by radical 2. If I did that, 12 divided by radical 32 times radical 2, I get the same answer?
Yeah, you get 12
Yeah,
radicals.
I get 12 over radical 16, which is 12 fourths, 3. So I would have gotten the same answer doing it that way. Does everybody understand that? There's like two approaches to this. If I was doing this problem, I probably would have done it the way I did it the first time. Even though it might seem like it's a little bit less work doing the stuff in blue, I didn't redraw pictures and things like that, so it seemed like less work. But I actually think it's a little bit easier if you can get the function in terms of the variable you want at the outset. It just makes it less work at the end. And that way you won't stop early. Like I bet you if you stopped early at some point, you'd get one of these other answers. You know what I mean? You just have to be careful about that. Any questions on that? Okay. Thanks, Diego. All right, Molly? No, Logan, sorry. Word. If it's free response, you can pick a different question. 82. So this is a calculator question. Use the e to the exponent, it's easier. It's above ln. Second, and then the ln. Yeah. You're still on second. Oh, you're on alpha lock. All right.
Yeah.
What are those?
The brackets.
Bracket.
Oh, okay.
Brackets. It doesn't matter. You can use brackets, just as long as you know you're using brackets. Okay.
now it's current.
What's it? Yeah, no, dude. All right, if it's red, it means it's selected. So there you go.
What is this really talking about?
Not smart. Long time ago.
It didn't, the X didn't register.
We have everything's in the place.
Any problems with that?
Yes, Josh.
Absolute value.
That's true. What's the difference between the integral of velocity and the integral of absolute value of velocity? What does the integral of velocity give you? Displacement. Yeah, so you have to somehow insert, you know whatever you do.
Yeah, how do I get that?
You do second entry, and then it's all editable. So you can go back and then just make sure you do insert, which is second delete.
The second already clicked and it's blue.
No, you got to go back further though.
Doing the absolute value of the function.
Yeah, I don't know if this is gonna work.
No, not these, not the.
Not there. That's in the limit of integration.
Outside the whole thing?
No,
Around the bush.
I don't know how this is gonna work.
Yeah, it'll work.
All right, do second. Go down.
Not there.
Go down.
Right there.
Insert math. Num. Choice one. Thanks.
Oh.
No, we get the idea.
Okay, yeah, that
So
we
what
did.
what would be the answer?
The answer ends up being 82 D. Okay? You can see why they put 1.85, right? That's probably a very common mistake that people make. Any questions about that?
Yeah, that would have got to be there.
It's definitely absolute value of velocity that you want to take the integral of. Same thing goes for if it's a graph of a velocity function. If it goes below the x-axis, you don't want the integral, you want the total area between the curve and the x-axis. See you guys, have a great day.
You too.
Hey, what's up?
Not much, how are you?
Good. Hey.
How are you?